Good morning once again. This is Mr. Rancourt, and I am going to show you how to do this paper. But before we talk about how to do balanced and unbalanced forces, let's go back and review real quick just what an unbalanced force is. So just write this. I'm going to write a U. That means unbalanced force. So an unbalanced force means that there is movement. Yes. What it means, more importantly, is that one side is using more force than another. And I want you to write this down. It means that one side is using more force than another. It might be pushing it harder, it might be pulling it harder, it might be lifting it harder, it might be pulling it towards the center of the earth harder. But unbalanced forces means that there's movement. In other words, that one side is using more force than another. Well, you know that balance is the complete opposite, so balance means that there's no movement. Oops, sorry. And that both sides, or all sides, and I'm going to write it like this, are experiencing, I wrote my pencil, are experiencing the same amount of force. The same amount of force. So balance means that there's no movement, or both, or that all sides of the object are experiencing the same amount of force. Yeah? And I'll go back to my previous example that I used right here. So right now, oops, let me go so you can see. So right now, I'm pushing to the left with just as much force as I'm pushing to the right, which keeps the ball in place, yes? And anytime I use more force, then the ball should move. Well, same thing like here too. Watch, if I use, you can't see. Right now, the forces are balanced. If I push down harder than I push up, then the ball will roll down. If I push up harder than I push down, then the ball will roll up, okay? And so that's really what that means right there, is that balanced forces means there's no movement and that all sides are experiencing the same amount of force. Okay? So I'm going to go through a couple of these examples and then I want you to do the rest of them by yourself. Really, the most important thing is that we talk about what to do when there's no picture here, okay? Because that's going to confuse you. But let's start with a warm-up real quick. So let's start with this one. So notice I have 10 newtons of force being pushed to the right, and I have 7 newtons of force being pushed to the left. Well, we already know that the forces are unbalanced because one side is using more force than the other. So what I would do right now is just go ahead and circle unbalanced, because you know that. I'll say that one more time. We know that one side is using more force than the other, and according to our notes up here, that means that the object is unbalanced, or that the forces, are unbalanced. Okay. So in this middle column, it just says net force equation, include the direction of force and label. All I want you to do is just show me simply your work. Okay. Well, we know that when the forces are working in opposite directions, we have to subtract. So all I need you to do is write this: 10 minus 7 equals 3. Don't forget to put newtons, because that's the remainder. So notice I took 10 newtons minus 7 newtons and got 3 newtons. Circle it. And since there's more force being applied to the right, yes, you're just going to tell me that the object moves to the right. And you can just literally write the word right. One more time, just so you understand how I got that. So we already said that they're unbalanced because one force is being applied to one side than the other. And remember, I told you that when one force is higher than the other, yes, when they're unbalanced, yes, when they're unbalanced, we need to subtract these two numbers. So 10 minus 7 equals 3 newtons. Don't forget to put the in. And since more force is being applied to the right than to the left, then the object will move to the right, which is what I want you to do. Include direction. Okay. Let's do number 4. So you're going to notice the difference between 2 and 4 is that there is no oppositional force. They're all working from the same side. So that just simply means that if I take my ball here, yeah, let me scroll out, and one finger is using 30 newtons and one is using 45 newtons, then the ball will be unbalanced, yeah? Because there's nothing preventing it from moving back the other way. There's no oppositional force. So again, it's unbalanced because it's not, because it is moving rather. So go ahead and circle unbalanced. But since they are working together, since these arrows are pointing in the same direction, we need to add. So all we need to do is do 30 plus 45 equals 75 newtons. Make sure that you put the N there. If you don't, I'm marking it wrong. Okay? And then since there's nothing pushing it to the left, it's all going to the right. You know that the direction goes to the right. I'll explain that one more time a slightly different way. So we know that it's unbalanced, okay? And the reason why we know it's unbalanced is because one side is pushing with more force than the other, yeah? Like this side is obviously pushing with more force than this because there's no force over here, so it's unbalanced. So the reason why I added my two numbers instead of subtracting like I did up here was because these two arrows are working together, yes? So we're combining the forces here. We want to know how much total force there is. Well, the total amount of force is 75 newtons, and it's pushing it to the right. Okay, so let's back up real quick and let's do number one. Here's what I would suggest you do, and you've got a little space to do this. What I would do is I would simply just draw a force diagram. So just draw a little box right here, okay? And it says there's 50 newtons going to the right. So what I would do is I would just draw my little arrow and write 50 in, yeah? And then there's 100 newtons going to the left. Make sure, I've told you, that these arrows have to be the right size. So if we're going to make this 50, we need to make this twice as big. 100 newtons. Okay. Well, now you know how to do it. Since one side is pushing with more force than the other, it's unbalanced. And since the directions of the arrows, or the vectors rather, are in opposition, we're just going to subtract. So 100 minus 50 equals 50. And there's more force being applied to the left. So 50 newtons, circle it to the left. Okay, bosses? Now, let's do number 7, because 7 looks different than all the others because they're using vertical force instead of horizontal force. In other words, the arrows are going up and down. Don't let that confuse you. Yeah, you're still going to do the same things. Yeah, instead of just it being pushed to the left or the right, it's being pushed down or up. Okay? And if you want, if that really confuses you, just turn it to its side there. Yeah? But just know that you've got to mention up or down, not left or right. Okay, well, let's do it. Well, since there's more force being pushed up than there is down, you know it's unbalanced. And you know since the direction of the arrows is opposite that you have to subtract. So 14 minus 10 equals 4 newtons. Yeah? And more force is being pushed up than down. Yeah? So it's going to go 4 newtons up, or upward. I would just put up. It's fine. Okay. If you have any questions, come see me. Don't forget to do the back. Hey, resultant force is just net force. You're literally doing the same thing on the back that you did on the front. Yeah? Don't forget to put newtons. You know what? I would just do that right now. And don't forget to tell me if it's moving to the left or to the right. Balanced or unbalanced. Thanks.